I have to do an answer key for this homework, so I thought I'd make you a video while I wrote out my answers. So sketch the graph, make a table of values below to help. And it's just a sketch. Notice we have no coordinates here. So I'm going to do -1, 0, and 1. And because it's to the 5th root here, I don't like what number times it. I could do 2 to the 5th power as an x value just to see, but I think this might give me enough. So this is 3 times -1 to the 4/5, which is -1 to the 1/5, and then to the 4th. Sorry, you don't need all those extra parentheses. So -1 to the 1/5, this is saying what -1 to the 1/5 is still -1, and then -1 to the 4th is +1. So this is, so at -1 here, we're going to be up at 3. 0, well, 0 to any power is still 0, so that's a point here. And then +1 is 3, so then 1 to the 1/5, and then to the 4th power. So 1 to the 1/5 is positive. 1 to the 4th is still positive, so that's up here. So our graph is going to go something like this. Now, ooh, -5/6. Yikes. Okay, I don't like a negative exponent. So I'm going to move the exponent, move the variable to the other side of the fraction and change the exponent to become positive. And I'm going to stick with my -1, 0, and 1. So -1 so that's 2 divided by -1 to the 1/6 to the 5th. So -1 to the 1/6, because that's an even radical, you can think of it like this. I can't 6th root a negative, so this number does not exist. So now let's go to the 0. Uh-oh, can't have 0 in the denominator. This number does not exist. Let's try 1. So this is going to be the 6th root of 1, if you like it that way, to the 5th. You could do this radical strategy over here with this one too, if you like that better. So the 6th root of 1 is still 1. 1 to the 5th is 1, so that's 2. So over here at 1, we're at 2. Let's do another number just to see if we're going to get bigger or smaller. So let's try 2 in the x. I didn't give myself enough room. All right, I'll do it right here. So that's the 6th root of 2 to the 5th. Oh, I don't know the 6th root of 2. Neither will you. So let's pick a better number. Let's pick, let's see. 2 to the 3rd is 8. 2 to the 4th is 16. 2 to the 5th is 32. So 2 to the 6th is 64. So let's pick 64. Way out here. So that's 2 over 2 to the 5th. Oh, and now I know that's 2 over 32. So that's a tiny decimal. And since 0 is undefined, I'm just going to, whoops, approach 0. I missed the point. So the graph is going to look something like that because these are undefined. And now this is small, way over here at 64. Okay, analyze the functions to determine which one grows the fastest as x goes to infinity. Put the equations in order. How do you determine? Okay, so to determine my answer, I'm going to look at the power, or the exponent. The coefficient means nothing. So 9, 1/3, 5 has no effect on my order. It's only the power. So slowest is the smallest exponent. Oh, now you can see that. Fastest is the largest exponent. So let's analyze our exponents. 3/4 as a decimal is 0.75. If you have 3/4, like in money. 5/4 is 1.25. 1/3 is 0.3 repeating. 1/2 is 0.5, and 4/3 is 1.3 repeating. Okay, so the smallest of these decimals is 0.3 repeating. So C is the slowest. 0.5 is next, so then D, and then A, and then B, and then E. On the back, change the radical to a rational exponent, sketch the function, and answer your properties. So the square root is rewritten as x to the 1/2. That is a parent function that looks like this. You could pick values like 0, 1, 4, the square root of 4 is 2, 9, the square root of 9 is 3, if you wanted to make a table of values. And then the cube root is x to the 1/3. And the values that are nice cube root numbers, oops, not 2, sorry, is -8, -1, 0, 1, and 8, which gives us these values. So it's a really shallow S shape, like that. So the square root and the cube root being very basic, radical power functions, you should just know what these shapes look like. It's the best, and they're gonna come up a lot. Okay, the domain starts at 0 and goes to infinity, or you can say it this way. Same thing with the range. And behavior, so as x goes to -infinity, y goes to, well, that does not exist. There is nothing over here at -infinity, and I'm sorry the phone camera keeps shaking. I'm on a wobbly table. To the right, x goes to infinity, y goes to infinity. This is going up. It is neither symmetry. It is continuous. It is increasing on the whole domain. It's not decreasing. The x-intercept and y-intercept are both 0. Okay, for the cube root, domain is all real numbers, and so is the range. You can write that this way if you like. And behavior, as x goes to -infinity, y goes to -infinity on this side. X goes to infinity for the right, y goes to infinity. It is odd. Has that origin symmetry. It is continuous. It is always increasing. And it also has an x and y intercept, of 0. Okay, determine if even, odd, or neither. It doesn't specifically say whether I have to do this algebraically or not, so I think I'm going to use numbers. I'm going to plug in 1 and -1, and see if I get the same, opposite, or a whole mix of different things. So -1 to the 3/5. I'll do my work down here. If you like to think of this as the 5th root cubed, you can. So -1 to the 5th root is still negative. Cubed is still negative, so that's a -2. If I do that for +1, the 5th root of +1 cubed, well, positive is going to stay positive, so negative and positive, those are opposite, so this is an odd function. Okay, I'm going to repeat that process. I'm going to turn this to the radical, the 6th root of x to the 5th. I think you might like that better. If you don't, you can leave it as an exponent. It's totally fine. The 6th root of -1 to the 5th. Well, automatically right here, -1 to an even radical is impossible. We can't take an even radical of a negative, so that does not exist. So if there's nothing on the right side of my graph, this is a neither function because it's not going to have symmetry on either side. All right, one more. The cube root of x to the fourth. All right, the cube root of a negative is still negative, but negative to the fourth power will become positive. So when I do that, the cube root of a positive is positive to the fourth, still positive. These are the same number, so this graph is even. And last but not least, if y varies inversely as the fourth root of x. Okay, well first, that's what this means. So varies inversely is multiplication of those variables will equal a constant number. Oh, look, they give us numbers, 7 and 81. The fourth root of 81, so what number times itself 4 times is 81? Is 3. So 21 is our constant. Write the power function. That's why it's called a power function with that radical. So y times the fourth root of x for this situation will always equal 21. So this is our answer. And now you are done your homework.